The ocean floor off the coast of Java just moved, not shifted, not trembled, moved. And what rose from that movement in the early hours of March 2025 is something that Indonesia's disaster agency is struggling to put into words that won't cause mass panic. They are failing. Anak Krakatau, child of Krakatau, the volcano born from the ruins of its own catastrophic parent, has entered a phase of activity that volcanologists are calling unlike anything recorded in the modern era. Steam columns punching 4 kilometers into the atmosphere. Pyroclastic flows racing toward the waterline at 200 kilometers per hour. And beneath the surface, something far more terrifying than anything visible from shore. A wall is building underwater. Volcanic debris, lava flows, and collapsed flank material have been accumulating on the seafloor at a rate that Indonesia's geological agency admits they have never observed before. The underwater shelf surrounding Anak Krakatau has risen by an estimated 40 meters in less than 3 weeks. That is not geological movement. That is geological violence. And it is happening directly beneath one of the most tsunami-vulnerable coastlines on the planet. Here is what the official statements are leaving out. In 2018, a partial flank collapse of this same volcano triggered a tsunami that killed 437 people with zero warning. No earthquake preceded it. No alarm sounded. Families on the beach at Anyer and Kurita were struck while a concert was still playing. The wave came out of darkness and silence. That 2018 collapse involved roughly 0.64 cubic kilometers of material entering the ocean. Researchers now monitoring the current underwater accumulation estimate that if the present buildup fails, if it slides, the volume entering the water could be 3 to 4 times larger. 3 to 4 times larger than the event that gave no warning and killed hundreds in minutes. 6 million people live within the direct tsunami impact corridor stretching from Lampung province in Sumatra to the western coast of Java. Anyer, Serang, Bandar Lampung, Merak, port cities, fishing communities, industrial zones built at sea level. The Sunda Strait, the narrow channel between Java and Sumatra through which Krakatau has presided for centuries, acts as a natural funnel. A tsunami generated in the strait does not dissipate across open ocean. It concentrates, it accelerates, it arrives at populated shores in as little as 15 minutes from the moment of collapse. 15 minutes. Indonesia's current early warning infrastructure for this specific threat, tsunamis generated by volcanic flank collapse rather than earthquakes, remains, in the assessment of international disaster risk experts, critically inadequate. The earthquake-triggered warning systems that dot the ocean floor detect seismic displacement. A flank collapse produces a different signature. It can slip into the water in relative seismic silence, generating a wave before any instrument designed to catch it has time to process what it is measuring. This is the precise mechanism that killed people in 2018. Nothing has fundamentally changed. Dr. Yuningsi Harjo of the Indonesian Center for Volcanology and Geological Hazard Mitigation issued a statement in mid-March placing Anak Krakatau at alert level 3, one step below the maximum. The statement used measured language. It spoke of increased volcanic activity and elevated monitoring protocols. What it did not say, what the data behind that statement implies, is that the underwater shelf now pressing against the underwater shelf, volcano's southwestern flank, is under a degree of pressure that has no recent historical parallel for this system. Scientists studying the 1883 eruption, the original Krakatau event that generated a tsunami killing over 36,000 people and was heard 46,800 kilometers away in Rodriguez Island, note that the precursor pattern currently being observed shares characteristics with the weeks before that catastrophe, not identical. Scientists are careful about that word, but similar enough that 3 separate volcanology teams have independently filed priority escalation requests with the International Association of Volcanology and Chemistry of the Earth's Interior, priority escalation. The scientific community's version of a raised hand in a room that is pretending to be calm. Beneath the Sunda Strait, tectonic forces that have shaped this region for millennia are not passive observers to what Anak Krakatau is doing. The volcano sits at the intersection of the Indo-Australian plate, diving beneath the Eurasian plate, a subduction zone that has produced some of the most violent geological events in recorded history. The 2004 Indian Ocean earthquake, magnitude 9.1, originated along this same fault system. The energy stored in this region is not theoretical. It is measurable, documented, and accumulating. Geologists tracking the interaction between the current Krakatau eruption sequence and the deeper subduction stress field describe what they are seeing as a feedback loop. As Anak Krakatau expels material and the pressure within its magma chamber fluctuates, microseismic events ripple outward along the subduction interface. These microevents, individually insignificant, are collectively releasing stress in a pattern that some researchers believe may be loading adjacent fault segments. The question being asked in monitoring centers from Jakarta to Tokyo is one that no computer model can yet answer with certainty. Is Krakatau releasing pressure or building it? What makes the current situation uniquely dangerous is not any single data point. It is the convergence, an actively erupting volcano with documented flank instability, an underwater debris accumulation growing at anomalous speed, a tsunami warning infrastructure with a documented gap in detecting volcanic origin waves, 6 million coastal residents, many of whom have no realistic evacuation route that could be executed in 15 minutes, and a regional tectonic environment already at elevated stress following years of increased seismic activity across the Indonesian archipelago. Each of these factors alone would demand attention. Together, they constitute what disaster risk specialists call a compound hazard scenario. And compound hazard scenarios do not follow the rules that emergency plans are written for. They do not follow the rules that history prepared us to expect. The ocean between Java and Sumatra has been the stage for two of humanity's most catastrophic natural disasters. In 1883, Krakatau rewrote the map of this strait and the global climate for years afterward. In 2018, its child demonstrated that the danger had not diminished. It had only been sleeping. It is not sleeping now. Here is section 2 of your script, words 1001-2000. The morning of March 18, 2025 began like any other along the Banten coastline. Fishing boats were returning before sunrise, their nets heavy with the night's catch. Children in Annier were already walking towards school, backpacks bouncing in the early light. Vendors along the beach road were setting up stalls, arranging plastic chairs, boiling water for the first coffee of the day. Normal, ordinary, the kind of morning that makes people believe that yesterday's news about the volcano was exaggerated. Then the water pulled back. Not a wave, not a surge, a withdrawal, the ocean retreating from the shoreline as if the sea itself had decided to leave. Fishing boats that had just docked suddenly sat on exposed wet sand. The harbor floor, visible for the first time in living memory, glistened in the early light. Children stopped walking and stared. Vendors froze. The fishermen, the ones who had heard the stories, who had fathers and grandfathers who described this exact sensation from 2018, started running before they could explain why. They did not wait to see what came next. This is the moment that emergency planners call the recognition gap, the terrifying window between when nature signals its intention and when the majority of people understand what that signal means. In 2018, that gap cost hundreds of lives. People stood on the beach filming the retreating water on their phones. They sent the videos to family members. They wrote captions. By the time those captions were posted, the wave had already arrived. The recognition gap is not a failure of intelligence. It is a failure of preparation. And along the Sunda Strait coastline in 2025, the preparation has not meaningfully improved. Indonesia's National Disaster Management Agency, BNPB, has invested significantly in earthquake-triggered tsunami warning infrastructure since 2004. The deep ocean buoys, the seismic sensors, the coastal sirens. This network represents genuine progress, but it was designed around a specific threat model. A large submarine earthquake displaces the ocean floor. Sensors detect the anomaly. A wave is modeled. An alert is issued. Sirens sound. People move. The system, when functioning correctly, can provide coastal communities with 20 to 30 minutes of warning for earthquake-generated tsunamis. Anak Krakatau does not generate earthquake-generated tsunamis. What Krakatau generates is a collapse-triggered displacement event. Material enters the water not from below but from the side, a lateral mass movement that shoves the ocean horizontally before gravity pulls it into the characteristic wave formation. The seismic signature of this process is fundamentally different from a subduction earthquake. It is shorter in duration, lower in magnitude, and easily misread by automated systems calibrated to detect the longer, deeper rumble of tectonic movement. In 2018, the warning system did not fail because it malfunctioned. It failed because it was never designed to catch what Krakatau actually did. 7 years later, this gap has not been closed. The International Tsunami Information Center published an assessment in late 2024, noting that volcano-generated tsunami detection remains one of the most significant unresolved challenges in global early warning infrastructure. The technology to detect underwater mass movements in real time exists in research environments. It has not been deployed at scale along the Sunda Strait. The political and financial commitments required to build the Krakatau-specific warning system have been discussed in Indonesian parliamentary sessions 4 times since 2018. Each time, the discussion has concluded with a committee recommendation. Each committee recommendation has produced a feasibility study. The feasibility studies sit in ministry filing systems while the underwater shelf around Anak Krakatau continues to grow, 40 meters higher than it was 3 weeks ago. Meanwhile, the evacuation mathematics along this coastline refuse to improve simply because officials wish they would. The western coast of Java between Anyer and Merak is home to dense, informal settlements built in the years since 2018, communities that moved back to the coast because the sea is where the work is. Fishing is not a choice for most of these families. It is the entire economy. The road network connecting coastal villages to higher ground was partially upgraded after 2018, but the upgrade assumed orderly, pre-warned evacuation. It assumed that residents would have 30 minutes, maybe more. It was not designed for 15. It was not designed for 10. It was not designed for the scenario where the first indication that something has happened is the water pulling back from the shore. And there is a detail in the 2018 post-event analysis that disaster planners rarely discuss publicly. When the tsunami struck that December night, the areas with the highest casualty rates were not the areas closest to the water. They were the areas where the roads to higher ground were narrow, where vehicles blocked the path, where the evacuation route bent and slowed and trapped the people trying to use it. Distance from shore was not the primary determinant of survival. The ability to move, fast, unobstructed, without hesitation was. That calculus has not changed. The roads in many of those same communities have not changed either. 6 million people. 15 minutes. Unchanged roads. An undetectable wave. Volcanologists monitoring Anak Krakatau in March 2025 are watching a specific indicator with an intensity that they do not broadcast to the public. The southwestern flank, the same flank that partially collapsed in 2018, is exhibiting ground deformation readings that suggest internal pressure is redistributing toward the base of the edifice. In plain terms, the volcano is being pushed from within toward its weakest structural point. The 2018 collapse removed material from that flank, leaving the remaining structure steeper, less supported, and more vulnerable to exactly the kind of internal pressure now being recorded. The volcano remembers where it broke before, and it is pushing there again. Satellite radar interferometry data processed by the European Space Agency's Copernicus program shows the southwestern flank has displaced outward by approximately 23 centimeters since the current eruption sequence began. 23 centimeters of outward movement in a structure sitting partially above and partially below the waterline, a structure whose 2018 partial failure from a smaller displacement sent a wall of water across a strait and killed 437 people before dawn. The number that keeps appearing in the technical literature on Krakatau's current state is not a death toll projection. It is a volume estimate, the volume of material that could enter the Sunda Strait if the southwestern flank fails completely, the number that 3 independent research teams have arrived at through different methodologies but convergent conclusions. The number that makes the 2018 event look like a rehearsal, 2.4 cubic kilometers. The ocean is not waiting for permission. The shelf is not waiting for a committee report. The flank is not waiting for a feasibility study to be read and actioned and funded and built. Physics operates on its own timeline. Indifferent to bureaucratic process, indifferent to the fishing boats returning before sunrise, indifferent to the children with backpacks, indifferent to the vendors boiling water for the first coffee of the morning along a coastline that has already been struck once and has not yet been made safe for the 6 million people living in the shadow of a volcano, that is, right now, pushing toward the place where it already knows it can break. The Sunda Strait is watching. The only question left is whether anyone is watching back.